Thank you for joining the February 22 meeting of the ASCE Capital Branch. We're excited today to be hearing about continuous connected automated vehicles. First, a few announcements. Actually, I'll just direct you to the chat, or maybe one of the other officers could repaste some of those. As I know, you only see the chat from when you log in, but there's an announcement there about our meetup this Thursday, project awards, and meeting another person on the board. And next month's presentation, fourth Tuesday, will be on tunnel safety. I'd like to introduce our officers. Now that they turned off their camera, sorry. Brett Hofstedt is our secretary. Do we have Richard, our treasurer? Brett, by the way, is leading up our meetup on Thursday. We have Bradley, who is our president-elect for the section. So the section is a step above the branch. So glad to have him also at the technical end. And we have Steve Freitas, a member at large on our board, helping out with social media and perhaps getting some of those life members together. We have quite a few of those. So if there are no other announcements, we'll move on to the topic of the day. Connected and automated vehicles, that's CAV for short. Brian Simi is the Office Chief for Traffic Operations Research and leads the Connected and Automated Vehicle Research Program for Caltrans. His career has seen the progression from timed intersections to metered traffic flow to potential CAVs. Most recently, and pertaining to today's topic, Brian's office has completed the development of a CAV strategic plan for the department that will serve as a blueprint for future CAV deployment efforts. He oversees a staff of 16 engineers that work on over 70 active research projects covering the disciplines of traffic operations, safety, modal design, and aeronautics. And in his spare time, why not more transportation? He's a cyclist. So members and guests, I now present Brian Simi. Brian, take it away.
Great, thanks, Sue. Hopefully you can hear me okay?
Mm-hmm.
Great, thanks for having me, and glad to meet everyone virtually, and thanks for the opportunity to discuss connected automated vehicles with you. I'm going to try sharing my screen here again, and let's see. Hopefully everything's still working. All right, can you all see the screen?
Yep.
Great, super. So yeah, thanks again for having me in the introduction, Sue. So yeah, basically I've been working the last 2 years with the Division of Research Innovation System Information at Caltrans, lovingly called DRISI, or DRISI, some people call it, and so I know we've got a few people on the call that I've worked with both the Caltrans and Lee from DRISI as well. So great to be speaking to you. A little bit of background about myself that Sue kind of already went over it, but in addition to the 2 years I spent the previous to my 2 years at DRISI, I've been at headquarter division of traffic operations, where I was working in the office of technology innovation, and so I was working on CAV as well at that point in time, and in helping from the traffic operations division perspective. So let me jump right into it, and let's see if I can advance slides here. There we go. So kind of the agenda kind of put together today was just talk really quickly about the sort of definition of what a connected and automated vehicle is. There is some sort of confusion out there in the media. There's a lot of misconceptions about it. A brief history of what Caltrans' role in CAV has been, some of the potential benefits, and the scope of Caltrans' responsibility and activities related to CAV. Also talk a little bit about the CAV strategic plan and implementation plan efforts currently underway at Caltrans, and the future of CAV in California, and some of the challenges that we're facing. So I don't know if I need to really sort of belabor this slide at all, but essentially one of the reasons why we're doing this is, we've got many transportation challenges and related to safety, mobility, and the environment. Upwards of almost 40,000 people a year die on our highways, and 1,500 fatalities just on state highways alone. So about 4 people a day, unfortunately, lose their lives on our state highway system. And that's just a state highway, and about 9 a day in California alone. So we're really trying to focus, see what we can do about using this CAV tool as a way to address all of these concerns, and then as well as sort of trying to address climate change through the environment and reducing emissions. It's also, the CAV is also in line with the Caltrans priorities, 5 priorities, as outlined by our director, Tokes. Our current director, he's going to soon be our agency secretary here shortly. So safety, and we feel that CAV is called the promise to reduce fatal injury crashes on the state highway system. The number has been stated as 94%. That's probably a little overstated, but still, we feel that there's going to be significant reduction in these collisions, and that CAVs really are going to be help us address the vulnerable road user population. So that's improve, bike and peds, and so we're looking to hopefully that will address that. Will help address that challenge. And then driving, of course, trying to achieve the Towards Zero Deaths and Vision Zero goals that we have nationally. And as well as improving sort of modality, improving people's ability to get from point A to point B, also addressing innovation efficiency, and then of course, partnerships, because without partnerships, this kind of a program would not be successful. And again, it's also in line with the Caltrans 2024 strategic plan. And so one of those things that having to be innovation, but really kind of touching on a lot of sort of cross-functionally or cross these different silos, trying to address the different, safety, enhancing the network and all those things. So it's really in line with the strategic plan. And then also there's sort of a mention of it in the Senate Bill 1, it's sort of the Road Repair and Accountability Act, which is also known as SB 1. And there is, that was signed into law in 2017, and there was reference to using advanced technology and communication systems in transportation infrastructure that recognize and accommodate advanced automotive technologies that will provide infrastructure to vehicle communications for transitional or full autonomous vehicle systems. So it's kind of vague in the law. I mean, it states this, but then there's not necessarily sort of a direct real teeth to it, but there is sort of that recognition that this is a technology that's coming up in the future, and that we're going to sort of apply to our transportation network going forward. Just a little bit about area of responsibility, because some people, probably most of the people on this call know this already, but just to be clear, because some people maybe don't know what the limits of what Caltrans can or can't do, and then within the realm of connected and automated vehicles. So our parent agency is the California State Transportation Agency that had been led by Secretary Kim, which will now be led by Secretary Tokes, who is our current Caltrans director. They oversee the 4 departments and that would be involved with connected and automated vehicles, and one of those being CHP, obviously from an enforcement standpoint. So they're responsible for handling all the enforcing all the laws. DMV is responsible for AV regulations, and then Caltrans obviously responsible for the infrastructure, the operation and maintenance of the state highway infrastructure, and then the Office of Traffic Safety. And so the traffic safety is more responsible for sort of that public outreach piece, public education, driver education, to understand sort of what CAVs can and can't do. So that's been something that we've been working together as a team for a few years now, with the agency, along with the agency, and working on connecting automated vehicles going forward, and been more recently through the AV kind of the AV side of it, right? Automated vehicle side. So just some terms that I'll probably throw around, and I'm sure there might be, feel free to put questions in the chat as well. That if you hear something or say something that you don't recognize or would like to me to clarify, absolutely put that in there because I will probably ramble off and give you some sort of acronym alphabet soup here. So AV, automated vehicle, so that's the general term that we use for for systems that assist the driver in operation of a vehicle. These levels are defined by the Society of Automotive Engineers, and there's a standard for that, and I'll show you that in just a second. And then connected CV is connected vehicle. That's the vehicle that's wirelessly connected to its surroundings, or it could be other vehicles, infrastructure, pedestrians, bikes, etc. It doesn't necessarily have to be a physical device in the car. That a lot of cars now that come off the line have a connectivity through like your manufacturer. So if you have a GM vehicle, that data is being sent to GM all the time, and so that's connected. You just don't, maybe people maybe on there so they're aware that is connected. And then ADAS gets referred to sometimes as automated driving assistance system. So that's more like what your car, a lot of cars may have coming off the line, which is things like emergency braking, lane keeping assist, those kinds of things. And then automated driving systems is more like gets into more of the actual AV piece of it, where the cars are driving themselves. And then operational design domain, we mean there is that the car has a certain conditions in which it can operate in sort of these what we call highly automated scenarios, and I'll get that in the next slide. And then we try not to use the term autonomous. It gets thrown around a lot in the industry, to the media. That's what people like to refer to it as, but a lot of times really technically autonomous means it can do anything without any kind of intervention, and so the highly automated, what we like to refer to instead is highly automated vehicles. And this next slide shows sort of this matrix of what that looks like. So SAE has different levels from level 0 to level 5. So level 0 is, you're just driving your car, you have no features to help you drive the car. So kind of old school for those of us, been around long enough. It's just, old fashioned, just, driving your vehicle. There are some, as you go up if you look at this and you go from left to right, you see levels, as you increase in levels, then there's more opportunity for automation. So things like automated acceleration or braking, if you have adaptive cruise control, lane keeping assist, those kinds of things. And then as you move to like a level 3, level 4, level 5, that's where then the car actually does a majority of the driving, if not all of the driving. So level 3 is sort of that transition where you're driving it, and if something happens, or the car is driving, we'll say the car is driving itself, you're sitting in the driver's seat, you may have to take over. Whereas level 4 and level 5 is completely automated. So it's, and we sometimes refer that as highly automated vehicles. So 4 then is in more of it's got to be within a certain operational design domain, whereas 5 theoretically can drive anywhere, right? So that's sort of just a real quick tutorial on the SAE levels as far as AVs are concerned, the definition of AVs. So then we get into connected and automated vehicles. Sort of that concept in general is really relating to the combining of the two. So we have connected vehicles, which I mentioned is sort of that wireless connectivity to something. And then there's the automated vehicle, which then got some levels of automation, and then they may not have a actual connection to anything. So no, they may not have a connection to the infrastructure or anything like that. They may have a connection back to their mothership or something like that to get data, but there's no interaction with the cars around it. So the idea is that then we would like to see, right, is that both of the best, the best of the features combined into one vehicle. So an example of like an AV or of a automated vehicle that's not connected would be like a Waymo that's currently in operation in Phoenix and in San Francisco, where they're operating and they don't interact with, they don't communicate with their surroundings in that way, right? They rely on sensors to assess the environment, and Tesla's another one, right? So whereas Tesla is more of their lower level of automation, and that's one of the things where we get into conversations about what Tesla thinks is automation versus autonomous, right? And I don't know if people saw that in recent discussion with our DMV about they sort of, their lawyers had to sort of back off and say, yeah, we're not fully autonomous, whereas maybe the literature says otherwise, right? So because you're always trying to sell vehicles, right? So just a little bit about, so DMV's role is to manage or to regulate AVs. This is their just kind of a real quick sheet on kind of what they do and where we're at in California with AVs. So we currently have, let me back up just a minute. So the DMV requires AV manufacturers to be registered. They have a permit when they're doing operations. So they currently right now have 50 manufacturers authorized to test AVs with a driver. We have 7 that can test without a driver, and then 3 are actually approved to deploy AVs on public roads, completely. So that's happening in San Francisco with I know Cruise and GM Cruise and the Waymo, which is the same one as what's happening, what they're deploying in Arizona. So they also have to have the drivers are permitted. So they have about 4,000 active test drivers with 132 driverless vehicles currently operating right now. And so they're also required to report traffic collisions. So about 408 traffic collisions and then 12.6 million miles driven. So they're required to post disengagement reports to tell DMV how well these vehicles are operating. And there's some limit to how useful the reports are, but it does give us an indication how well that is progressing. So you see the increase in number of autonomous miles driven, 4.1 million as of last year. There obviously a dip during the pandemic, but that number is continuing to grow. There's continuing interest in this area. And then just on the right here is just a little bit of background of kind of where the regulations. So they only allow right now in California vehicles operating under 10,000 pounds are allowed to operate on the state highway system. So some Caltrans background in CAV. So Caltrans back before the turn of the century was involved in the National Automated Highway System Consortium. So it was a demo that we partnered with several other entities and did a demo down on I-15 in San Diego. We also were working with UC Berkeley, California Path program. We ended that work. So the part of that demo is they did run vehicles on I-15, and that's in the screen background there that you see. But essentially these cars were linked wirelessly, had radar on them, and so they followed full freeway speed, close distance at full freeway speed. That work ended in 1998. So there was no longer any funding. So then we also did, so following on that, we did some additional work for on bus automation in 2003. We worked on truck platooning, and we currently, so we've started truck platooning work around 2003. We currently have a follow-on grant project to actually use the truck platooning equipment in a what they call revenue service. So we're actually partnering with a company in Southern California, trucking company, and then going to be using that to transport, move trucks along I-10 to Texas, and then using the communications to help platoon the trucks. And that's not full automation. That's only just level 1, level 2 automation type of thing, where the vehicles are just following at a certain headway automatically, right? So there's still a driver in the truck, and they have to steer the trucks and that kind of thing. So but it does allow the trucks to be spaced very, very closely. So we're going to see that actually in the field in the next few months as part of an FHWA grant that we're working on along with California Path. And then we did a bus steering automation actually it was done in Oregon, but it was using magnets to help buses guide in a narrow trackway up near the university there at University of Oregon. So one of the things we feel that we're focusing on at Caltrans, or we should focus on, is safety through connectivity. So one of the things that you'll hear us talk about a lot is sort of this V to X piece of it. So vehicle to everything. So we talk about vehicle to vehicle to infrastructure, vehicle to everything. So meaning like bikes and peds. So that's sometimes referred to as V to P. And then it's utilizing, this is what we call low latency, high reliability, point-to-point communications. There's a couple of different standards that are out there that's referred to DSRC or cellular V2X. DSRC meaning dedicated short-range communications, and cellular V2X meaning cellular vehicle to everything. It's a little bit of a misnomer, only from the standpoint it's not really cellular. It's not using the cellular network. It's actually a direct radio link, so it's very low latency. And I'll get into the details of that a little bit more. And maybe it's maybe too much detail for this audience, but you know, I just want to make sure we're covering everything. And then it's also involves what we call roadside units. So that's the devices that sit on infrastructure. And these are typically integrated with like a traffic signal control. And then as well as then the onboard units, which then the onboard units are in the vehicle, which then that's the device, you know, communicating to the car, telling the car, you know, providing the car information. The car is also sending information to the infrastructure, so we can use that information as well for different applications. And as I mentioned earlier, there's cloud or cellular systems can support some mobility applications. There's a concern that, you know, we don't want high latency of communications, just because if it's a safety application, you know, if there's something that the driver needs to be aware of like immediately, we typically don't want to rely on sort of like a cloud or cellular communications, because that could be a life-saving type of application. But in many applications, regards to mobility, having to do with maybe traffic signal, what we call eco approach and departure, which I'll mention a little later, it may be fine for that, right? So they may not require as much infrastructure placement, and it can be more broadly applied across the transportation network. Some of the areas we've been working on in research at Caltrans research has been, you know, we're engaged in technology development, applications, and standards. We've been doing some upgrades to our traffic signal controller programs to accommodate for connected and automated, well, I'll say connected applications. Looking at design, standard design for intersection upgrades for CAV compatibility, having to do with mapping. So one of the things that's really kind of key for these kinds of applications are highly accurate. So, you know, highly accurate mapping and GPS, so that we're looking at those ways to improve that, as well as security credential management system. That has to do with the communications and making sure the communications between the infrastructure and the cars are secure, right? So we don't want people hacking into them, and we want to make sure that the information is reliable. And then broadcasting reception capability. This has to do with getting information from, let's say, a traffic signal controller and getting signal, what we call signal phase and timing from the controllers, getting map information. That's the map, that's the information at the intersection, let's say. And then as well as essentially, again, going back to the GPS messaging, any correction, any what we call correction messages that will improve the accuracy of the location, so that you know where the car is physically within the environment, within that intersection environment. Some of the applications that have been worked on in various research projects and continue to work on are things like eco approach and departure. That has to do with as a car approaches an intersection, that they know when, how much green time they may have, or when the red phase may be over, when the green may show up. And so this might help cars from maybe not speeding. Of course, we don't want to tell cars to speed up before the light turns red, so we do have to be aware of that. But essentially, it has to do with trying to get cars more smoothly through the intersections and through a corridor. Transit signal priority, red light violation warning, mid-block pedestrian detection, bike signal priority, lane closure warning. There's a lot more interest in work zone information. That's something else we're looking into. And then pedestrian mobility, as I mentioned before about sort of the vulnerable road users piece of it, there's a lot more focus on that. So we're hoping to do more research in those areas. And then working on standards and regulation development, we're involved in various transportation research boards, NCHRP and USDOT sponsored projects as well. And we do have so we have a connected vehicle test bed that's located in the Bay Area. We started about 2011. It's located in the peninsula on El Camino Real or State Route 82. That's near Stanford, Palo Alto area. We've got 7 miles of 31 intersections that are equipped with roadside units. These are transmitting information every 1/10 of a second to properly equip vehicles. We are currently compliant with the SAEs provide standards, standard messaging. We're compliant with the 2016 version. We're looking to upgrade that here as we move forward. There's just been a recent update, as well as we're doing a backhaul communication with wireless with cellular, and hope to at some point improve that with fiber. And we are, like I mentioned, the SCMS Security Credential Management System. We're also going to equip the test bed with that to make sure that's all compliant and secure. So we've been doing, trying to help develop the roadside equipment design. It's essentially showing how this equipment should be installed. It could be installed or have best be installed. Things to address line of sight from a radio frequency standpoint. And then we've tested and developed various Caltrans focused applications. One of those being the eco approach and departure, which I mentioned earlier, and then transit signal priority. So we've been working with the Valley Transportation Authority, VTA, and the San Jose area, talking with them about equipping some of their buses with that. So it looks like I've got some. Apologize for the video. I might have the sun's now shining on my face. So I apologize in advance for that. Thanks, Lee. Here's an example of the schematic of what an intersection would like. The equipment, the physical hardware at an intersection for a roadside unit, communicating with our traffic signal controller. And so that's communicating information back and forth from a vehicle. We'd be getting information from the vehicle or back to or information from the controller back to the car. So we can send out things like when the signal might be turning red, so we can warn of a car that they may be maybe have the potential of running a red, right? So this is more of just a kind of in the weeds a little bit on the hardware, but that's kind of the equipment we have typically at the intersection there, or across the corridor. And this is what some of the physical installation looks like at a sample location. The roadside unit on the side of the pole, and the antennas on the mast arm. And then kind of just the overall intersection, what that might look like, and then where the different devices would be residing. So so we typically have a controller cabinet, and then this is where the antenna and the roadside units would be installed. And so that's how it's fairly unobtrusive, not a lot of equipment necessarily to install. And so we think it's, from that standpoint, it's not a huge, major infrastructure upgrade, if you will. And I think there was a comment here from Stephen about automated capability to stop vehicles. So right now there's not that kind of support. Typically, that's gonna be something that the auto manufacturers would support in some fashion. At this point in time, we're talking about just sort of warnings to the driver to be aware of that situation, because we don't necessarily want to be in the business of actually controlling cars. So that's kind of where what our limits would be as a state DOT, right? Some of the typical messages that we see that are their standards. Again, they're SAE standards, and this is again probably maybe a little bit in the weeds, but just kind of really quickly go over it. So the big thing is what we call the basic safety message. So that's information that's coming from the vehicle that's going to the infrastructure, and that's happening 10 times a second. So as you're driving your vehicle, it would be sending this information. It would be sending the heading, the speed heading, any other information that would help help us with potentially signal timing or just general information. We would be sending signal phase and timing from the intersection like again, I mentioned it would be telling us what the green phase and maybe what's left on during the green phase, when we expect the green to arrive again. And then the signal request message and signal status message relate to traffic signal priority. Essentially, when a bus shows up or whatever, it could send that request, and then the status message tells you whether you've gotten that request or whether that's been approved. And then another message relating to position correction, and then some road safety messages, again, from this would be from the infrastructure of the vehicle, and that would be more about like what's happening with lane closures to tell the driver potentially reduce speed zone warning. So you're approaching a construction zone, you should reduce your speed accordingly, right? And I see your question, Sue, is and I'll touch on that in just a moment, and so remind me if I don't cover it here. The eco approach and departure, this is just sort of a more, I guess, detailed look at what how that application works. Essentially, what's happening here is the cars are approaching a signal. The cars can transmit their speed and heading, but the traffic signal is also telling the cars, okay, this green is going to last for X amount of seconds. So, if you drive at this speed, you'll go through the intersection, no problem. Or it'll just tell you, don't bother, you're not going to make it. Don't try to race to get the green. And then as well as, start up, the cars are prepared when the light goes green, or is it it's about to turn green, that cars are prepared to continue moving forward. But essentially, it's to harmonize that flow through the intersections, right? This is sort of a detail of the transit signal priority. Again, this one shows sort of an example of a cloud-based implementation. So you can use either cloud-based or direct communication. So in this case, the bus can communicate directly to the intersection, or it can communicate through the cloud to get the information as well, to find out, when. And then essentially what the transit signal priority would do is usually just extend the green a little bit, and then, or you get an early force off from another, like a side street. So the idea being that if the buses meet certain conditions, that it needs to be on time, that it's maybe behind schedule a little bit, it's got a full bus, the occupancy of the bus is such that it's warranted to get that priority, then it'll do that. So it's not just an automatic thing, but it requires some communication back to the central application to say that's it's okay for this bus to go through this intersection, or get priority to go through this intersection. Some of the things we talk about, improvements to the infrastructure when we talk about AVs, because sometimes I talk about connected and automated vehicles, and so sometimes we talk about connected and sometimes we talk about automated, and they can be, sometimes the lines can blur. And specifically what this slide is showing is sort of infrastructure improvements to deal with, I'll say specifically AVs, right? So this is to deal with cars that now are equipped with better sensors, electronics on them to follow the roadway, and either as a level 1, level 2, level 3, all the way to level 5. What sort of improvements would we do as a department, as an infrastructure owner operator, to help improve the safety and mobility of those vehicles, right? And this is a little bit kind of to Sue, your question about the sort of the structure piece of it. There, for right now, what we've seen a lot of, at least, part of this is we rely on the AV companies to tell us, okay, what would you all like to see to improve AVs? One of those has to do with, like, we got rid of bot stots a few years ago, or the use of them, just bot stots without any background painting, without any background delineation, just because they weren't able to. I mean, we didn't get rid of them, just to be clear, we didn't get rid of them just for AV manufacturers, but they were also sort of, for us, were sort of a maintenance headache, right? So, but the striping is really important for them, and what we found is the contrast is what they're really looking at. So one of the things we want to do is we want to improve striping and signing, then help human drivers, right, as well as machine drivers. So that improved contrast helps humans, and it helps computer system, or computer drivers, or AV drivers. This also is going to help, improve during wet conditions. And I know probably some of you have noticed, some of our older striping is hard to see under some of these conditions, under the water, wet conditions. Also under different color pavement, right? So the white stripe on a PCC roadway is sometimes hard to make out. So we've looked at changing our standards to make that more clear, more visible. We're also doing a research project to look at orange striping to see that color, so that contrast is even more apparent. But we'd use that in construction zones, so that to tell people, okay, this is not your standard, this isn't your standard striping, or wouldn't be your standard delineation. Is normal because of the construction, right? So that's kind of what we're looking at. We've also done this research project to get more industry survey, get more industry feedback, and we're trying to get more information from them. And what we need to do is we're trying to partner better with them, and not only OEMs but the tier 1 providers. So that a lot of these car manufacturers, they're tacking on equipment from other vendors, other manufacturers, and so we're looking to try to talk to all of them to see what we can do to improve our roadway. And our challenge is really getting them to talk to us, right, and getting access to their data, because it's all very proprietary, and they don't typically like to talk to us in front of a bunch of other people, or even, and sometimes there's a challenge even in private. So that's something that we're continually, and that's a national problem that we're trying to address, work with others to solve. Just a real quick discuss about we do have a proving ground that we've designated down in the San Diego area, where we've been doing some testing. We've been doing some connected and automated vehicle testing down there. We partnered with Qualcomm. Qualcomm makes the cellular VDX type radios, standard radios. And so that's what so we've been working with them in Southern California. And in national engagement, just a really quick note on that is just one of our key things is we're trying to stay engaged at the national level. So we work with people, organizations like ASHTO, ITE, FHWA, ITS America. So they're more of a policy oriented, but have a huge influence at the national level. And of course, the Society of Automotive Engineers, who develops the standards. Statewide, or from a Caltrans perspective, we've been looking at just to talk about statewide policy efforts for a minute. So back in 2018, Governor's Office of Planning and Research led the effort to develop sort of these AV principles. They sort of don't want this AV development to go sort of unchecked, right? So Caltrans participated in the development of sort of just a real kind of a brief, one-page document. Essentially, the key principles being that the AV should be shared use, pooled, low emission, right size, multimodal, efficient land use, and then complete streets and equity. So they wanted to just make sure that all of these things are being considered as we have these continued discussions about AVs. So ideally, you don't want AVs driving around with nobody in them and creating more VMT, more emissions, more congestion, right? So they wanted to sort of give us that at least initial sort of framework, if you will, right? So Caltrans roadmap, taking the AV principles on the left here, we're looking at developing a few documents. One of them being the CAV strategic plan, which I'll mention in a moment, and then that along with the AV survey that was already done, and then they're working currently is work being done in the CAV implementation plan. All of these efforts are going to sort of try to coordinate and communicate what we're doing, what Caltrans is doing in this area, right? Within the scope of what we work on, right? And it's, as I mentioned at the beginning of the presentation about sort of what our roles are. We're not developing regs, so we're not telling people how to build cars. We're not telling people where they can drive cars. It's just how do we accommodate for them within our role, sphere of influence, if you will. And then our research program is really working with that, developing a CAV research roadmap, addressing gaps, and then doing technology pilots as well where it makes sense, right? And some of the initiatives, just to follow on, the strategic plan was completed in June. We have not been approved to release it for public consumption yet. Still awaiting at the governor's office for approval on that. And then we've got an implementation plan that's in the process of being completed in March, hopefully next month here. So just real quick, this was our CV strategic plan. Just again, the vision being safe, efficient, reliable, clean, and equitable transportation system supported by CAP technologies. Just really kind of, very high level. But part of that is, we want to develop a framework on how we want to prepare for CAV deployment. And so we developed some actions, about 40 actions for Caltrans to consider in the next 5 years. And so essentially building up making it sort of mainstream within the department and figuring out how to address the various goals of the strategic plan over the coming years, right? And of course, this is going to sort of fluctuate depending on how fast these technologies are deployed. And then in the Caltrans CAV implementation plan, similar concept. We're trying to it's basically looking at it from a lower level. So if you think of the strategic plan as maybe the 30,000 foot level, the implementation plan is more of the 10,000 foot level, where we're trying to get making that next step of how do we deploy this technology, right? And so it's providing guidance to our districts, our 12 districts, and then as well as their partners and local agencies. And also there's just a plug-in for our IT. There's an IT component of this, the telecommunication network. So there is sort of that infrastructure that needs to be addressed to that what we'll call this digital infrastructure. Broadband gets thrown around. So all of that also has to be considered as part of this plan as well. A couple of things that are going to be a challenge for us, and this going back to the connected vehicle discussion, is that the frequency that's being used is not required for vehicles to be equipped with this. So it's really right now we're relying on OEMs to voluntarily install this equipment, but we have a little bit of a problem because the FCC has recently made rules to reduce the spectrum that we were originally allowed to use, which was about 75 megahertz. Now we're down to 30 megahertz. And so that's creating a challenge for us in being able to support all the applications, eventually support all the applications using that limited spectrum. So, and we're also changing the standard from the DSRC I mentioned earlier to the cellular V2X. So this creates a problem, right? So this creates an issue where our auto manufacturer is going to install it where there's still this shift or this uncertainty in the spectrum. And so ITS America and ASCE have formally filed suit against FCC to prevent this reallocation, but we don't know what the outcome of that's going to be for quite a few months, right? So there's actually going to be a hearing. I think it was going to be any day now, actually, on this. So we're still kind of unsure about this particular aspect of it. So obviously, Ford and GM aren't going to start rolling, equipping vehicles and roll them off the lot, coming off the lot with this equipment if those are the unknowns. But they have made some voluntarily have said, we're going to start doing this in some limited fashion. So we are starting to see that. There is no NHTSA. There was originally a NHTSA regulation in 2016 that got rescinded when the administration changed, and so then there's been no further regulations national, from NHTSA. And so that's just going to impact us, going forward and how we manage these things. So moving forward, where Caltrans is doing we're trying to adjust to this rapidly changing environment. We'll continue to work with our state and local partners to develop a comprehensive plan, CAV plan. And we think that national vision engagement is needed, along with commitment from the OEMs. That's in order to really be successful. So there are a couple of efforts in that sense, or in that vein. So we'll see how those sort of materialize. And then there's also just kind of a plug for the IIJA. So there were AV references in the Infrastructure Investment and Jobs Act, and we're going to find out more about how those are going to be implemented in the coming coming months as they determine how to sort of implement that act. Not really any specific dollars per se, but more just at least they're acknowledging, okay, this is out there and there's a need for this, this activity, right? Or need to fund this activity. So that's kind of a really quick, it may not have seemed quick. that was kind of a little bit, maybe drink through a fire hose kind of situation. But anyway, that's just kind of where we're at right now at Caltrans. Happy to take questions. I see some questions in the chat. So Sue, however you want to handle that, be happy to.
Yeah, Brian, let me go ahead and do what I can to ask the questions that came in the chat, so you're not having to search around for them.
Yeah.
I think there's 7 or 8. So are there any AVs approved to deploy in the Sacramento region?
Yeah, so AV, no, the AVs have been approved to deploy. So the slide I showed you back at the beginning from the DMV, those are approved for deployment on the state highway system. So they can be deployed anywhere. Well, I'm sorry. Let me step back. Anywhere on this any road, right? Any public road, because DMV's authority goes beyond the state highways, right? So those AVs can be used anywhere. The ones that were approved, I think three different companies that have AVs or that actually are approved to run on the public roads. To my knowledge, they're only being operated in the Bay Area or Southern California that I'm aware of. But I don't know that they've been. It's not to say they can't operate in Sacramento. They just likely aren't, because their base of operations are typically in the Bay Area.
Okay. And then, do you understand or know whether or not there'll be any automated capability to stop all vehicles approaching a yellow light intersection as it's turning red?
Yeah, I think I touched on this earlier. Yeah, no, there's no foreseeable. We don't foresee a time when we would be doing that. That would be up to the auto manufacturers and how they want to interact with their operators.
Okay. And then, is there anything that you want the highway and bridge engineers on this call to know or do in order to accommodate these vehicles in the future?
Right. So that's a challenge, right? Like I mentioned earlier in the presentation, it's the AV. It's hard to know what they want as far as, I'll say, speaking from an AV perspective, because they won't tell us. There's some things like signing and striping. We have a pretty good idea with they want things maintained better. Which don't we all? Want better, clearer stripe delineation markings, readable signs, those kinds of things. I mean, because they read them. They don't want obscured signs or signs that are heavily damaged, those kinds of things. So that would be the biggest thing. And then, we just haven't got enough information to, I don't have enough information at this point to tell somebody, okay, well, you guys need to do X, right? I think it's really a matter of what the capability of the sensors are, because what these guys are using are cameras, radar, sometimes LiDAR. So LiDARs, using a laser, sort of a laser sensor. And so they're using those things typically, like in the case of Tesla, they're almost exclusively using video. So it's really a matter of whatever we put out there that we make sure is just sort of it's standard. It's sort of standard across the board, right? And it's maintained.
Okay. And then just as a side note, Brett, I think that he covered your question that was reworded as well. If you think differently, pop it in the chat and we'll re-ask it or ask it a different way. There's another comment here with a sort of follow-up question, in that we seem to be seeing less focus on automated or connected trucks and goods movement than we did 3 years ago. Seems to have shifted to passenger vehicles and cars. Mm-hmm. Are we really seeing that in real life, or is it an illusion? We're going to wait for the trucks and freight movement later. How's that work?
No, I think we're seeing a lot of. I'm hearing a lot of push on the freight side of it. Aurora, which was it's a big player in this area, was Chris Urmson, who worked for, I believe it was Google. came from their CAV side or the AV side as well. So there's been a big push on the goods movement. They're obviously with the trucking shortage and the whole delivery issue, the delivery chain. There's been a lot of focus on that lately. So we're seeing like companies like Too Simple, Aurora, come out and say, yeah, we're going to start they're doing testing in Texas and things like that, right? They're not doing testing in California because we don't have the regs to support it. So they're doing that in other states. But yeah, it's happening. In fact, I wouldn't be surprised we see that more. We see that almost sooner than the AVs, to be quite honest, just because there is a lot of capital, venture capital going in that area, and there's a lot of interest, I think, by businesses to go that direction. So, and I think there's less desire from the AVs. Only from the AVs would really be more from the robo taxi or the transportation side of it, right? The public, more from the Uber, Lyft type solution, right?
Yep. And then I know that you're not from the CHP and you're not from the DMV. There's a question in here a little bit about some of the stories that hit the news about vehicles that are getting in accidents and or violating the rules, yet there's somebody in the back seat or asleep in the car or whatever.
Right.
Do you know of any new requirements or rules that are going to really focus on having a licensed driver in the vehicle, and does that maybe play into that one chart that you had that shows no automation all the way to 100% automation? Anything you could share on that?
Yeah, I mean, the CHP and DMV are sort of actively addressing these kinds of issues. They obviously, those cars or people that are operating them, they're effectively operating them illegally, right? When they do that, right? So the person, I saw the news story of the person getting into the back seat, get his Tesla, and he basically starts it, says go home, and then he sits in the back seat, right? And then it gets in a wreck or whatever, and then he goes, whatever, I mean, so we try to arrest, we try to, the DMV or the CHP actually tries to, enforces that, and then DMV does the best they can as far as, enforcing, making that known to the vendors as well. And that's kind of why Tesla had to sort of come out in public and say, yeah, our cars are not autonomous effectively. So that even though they say, oh yeah, they'll drive by themselves and all kinds of stuff, but make all kinds of claims, but they really can't say that, right? So and the their lawyers have agreed. So that's about the best we can do, I think, from that standpoint. I don't know if I'll have to follow up with DMV and CHP to see what they've been doing lately. But in my understanding, they basically have interaction plans already developed to how do they interact with these kinds of vehicles. In case of like people sleeping or things like that, you've seen those stories where people have fall asleep in their car, and so the CHP ends up having to pull them over. Actually, what they do is they pull in front of them and start to slow down to a stop, and so the car is basically following that car in front of them, so eventually it stops the car, right? So so there is some of that, there are some of those challenges, I think, going forward for sure.
Great. We have two more questions and time for two more questions, so it's great. One more here on the big picture in coordination with adjacent states. Any sort of Caltrans, Oregon DOT, NDOT coordination?
Yeah, so with the coordination, we typically do that, at least for Caltrans. So we're on the Connected Vehicle Pooled Fund Study, and so we work with other states. That's a pooled fund study, so that means other states can join. And we have about 20 some odd states that are involved in that one. And so that's more on the connected vehicle side. So we work with them, and they may or may not be adjoining. Like Oregon. Oregon is I don't believe if they're on the connected vehicle one or not. But so we do have some of those partnerships going on, and then we've worked with with like Nevada and Arizona for the truck platooning. We work with them in coordinating some of the truck platooning efforts. So that's the one on I-10. So that's going through Nevada, Arizona, New Mexico, and Texas. So we do work with them, and so there is some level of coordination in that respect. And there's coordination on the AV side with like DMV. So the DMV will meet. They have sort of a national group that they meet with as well. And as well as some of the other national efforts that I mentioned in my presentation that we work with AASHTO, And so there's TRB and AASHTO groups that meet and sort of coordinate those efforts. And again, we're all sort of, that it's to prevent that patchwork of regulation kind of thing. So that's going to be a challenge as to how do we manage that, right? Because we want to be able to people to drive their AVs from state to state, right? So there is some of that going on, but again, it's more on the DMV, the regulation side of the house for when we talk about AVs.
All right, and the last question, this could lead to a bigger discussion, may not, I don't know, but there's a lot of other modes on the road besides just these vehicles, right?
Right.
It's pedestrian, cyclists, bus rapid transit, there's, light rail and whatever. What's the status of other research in these other modes and the conflicts that may exist between them?
Yeah, that's a great question. So we do have some research that we've been doing on our own within California. So we've been doing some research on detection at the intersections. So being able to detect, bikes and peds, and then that way we get that information. Let's say at a signalized intersection, we get that information and we know where the bikes and peds actually physically are in relation to the intersection itself, a reference point, and then as well as an approaching vehicle. So we can warn, drivers in an AV or a connected vehicle that, hey, there's a pedestrian in the crosswalk or there's a bicyclist nearby. So we are looking at trying to improve that communication and moving that data around so there's other vehicles can be aware of their presence, right? And then that work is also going on nationally, and then within the AV realm, it's like how do you interact with the pedestrians and cyclists? So the sensors are certainly need to be attuned to them, as well as even sort of that visual cue, right? With pedestrians and seeing an AV, and does a pedestrian walk in front of does it feel comfortable that the AV is going to stop? So there has been research done on that as well. So that is a huge concern going forward, is with how do we address the vulnerable road users and interacting with them.
Great. Thank you very much. I will turn it over to Sue and back out of here. Appreciate all of the answers and great presentation.
Thank you, Brian. Very comprehensive. I feel like I'm caught up on the latest and greatest, the work in progress. And I think the big question is for some of us in our 60s, will we see it yet in our lifetimes? Certainly the younger folks here have their work cut out for them, but I'm confident we're in good hands here. So reminder again that this Thursday is our meetup in Folsom. No agenda, just come and enjoy and relax at the end of your day. Don't forget the awards that are due in a month. It takes a little bit of effort to put together your package, but your chances are good. We've got 20 different categories. If you would like to get more involved and be on the board, we'd love to have you. Shoot me an email, and I hope to see all of you again next month for our talk on tunnel safety and what has been done in California since the tunnel fires 5 years ago. So thanks again, Brian, and everyone for joining in. Have a good afternoon, and this ends our program.